Hello dear students, welcome to my channel. In this class I am going to discuss about second chapter, very important 3 mark and 5 mark derivations. The previous video first chapter very important 3 mark and 5 mark derivations discuss ಮಾಡಿದೆ. So ಈ ವಿಡಿಯೋದಲ್ಲಿ second chapter ಅಲ್ಲಿ ಇರೋ very important 3 mark and 5 mark derivations discuss ಮಾಡ್ತಾ ಇದ್ದೇನೆ. First 3 mark derivations in discuss now. The first question 3 mark very important. State the properties. State the properties of equipotential surfaces. So equipotential surface means that is the surface on which electric potential is same everywhere. Surface on which electric potential is same everywhere. That is the meaning of equipotential surface. So equipotential surfaces are ಕೆಲವೊಂದು simple properties ಈಗ discuss ಮಾಡೋಣ. Very simple property, that is equipotential surfaces will never intersect with each other. Okay, very simple property though. Equipotential surfaces, equipotential surfaces, equipotential surfaces will never intersect with each other, never intersect with each other. And what type of equipotential surfaces produces around isolated positive point charge? That is concentric spheres, right? So concentric spheres or equipotential surfaces around isolated positive point charge. Concentric spheres. Concentric spheres or equipotential surfaces around isolated positive point charge. A very simple properties even on discuss ಮಾಡ್ತಾ ಇದ್ದೀನಿ. The third one is equipotential surfaces are closer, which means electric field strength is stronger. Equipotential surfaces are spread out further apart, which means electric field strength is weaker. This is also simple property. Equipotential surfaces. Equipotential surfaces are closer, which means electric field strength is stronger. Electric field strength is stronger. And equipotential surfaces are spread out. potential. Next property. Now, iterate two properties for better. Equipotential surfaces are closer, which means electric field strength is stronger. Equipotential surfaces are spread out. Equipotential surfaces. Potential surfaces are spread out. Spread out. Spread out, which means electric field strength is weaker, right? So actually three properties mentioned madara, more than sufficient, but two more properties mentioned madara better. Okay, now we get two more properties mentioned madara. And then the direction of electric intensity. This point is also very important. Actually, the needle could I go through. The direction of electric intensity is always perpendicular to the equipotential surface. The direction of electric intensity. Direction of electric intensity is perpendicular to equipotential surface. Equipotential surface. So, in the number of properties there. That means equipotential surface helps us to find the direction of electric intensity. Equipotential surfaces helps us to find the region of strong or weak electric field. No work is done in moving test charge along equipotential surface. Equipotential surface ಮೇಲೆ test charge na move ಮಾಡ್ತಾ ಇದ್ರೆ so work done in ಬರುತ್ತೆ zero. Okay, so ಇಷ್ಟು properties ಚೆನ್ನಾಗಿ practice ಮಾಡಿ. Equipotential surfaces will never intersect with each other. Concentric spheres or equipotential surfaces around isolated positive point charge, and parallel planes or equipotential surfaces in uniform electric field. So that is also the property of equipotential surface. And equipotential surfaces are closer, which means electric field strength is stronger. Equipotential surfaces are spread out, which means electric field strength is weaker. Okay, the direction of electric intensity is always perpendicular to the equipotential surface. Next question, hopefully. Derive the relation between electric potential and electric field due to a point charge. Derive E is equal to minus dV by R. So this is a very important repeated 3-mark derivation in this chapter. ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿ ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ ನೋಡಿ. First here, let us consider isolated positive point charge plus Q that is located at point O. Okay, O andre location, that is the location of isolated positive point charge. Line draw ಮಾಡಿ. Okay, so ಇದರ ಮೇಲೆ number of observation points ನಾವು choose ಮಾಡಬೇಕು. First point A, point B and the mention. Actually, this hand goes to infinity. A unit positive test charge plus Q naught is placed at point A. Due to plus Q at O, due to plus Q at O, plus Q naught at A, will experiences repulsive force, right? Due to plus Q naught, plus Q in the plus Q naught ಮೇಲೆ repulsive force act ಆಗುತ್ತೆ. So in terms of electric field, now F vector is equal to Q naught into E vector ಅಂತ mention ಮಾಡ್ಬೋದು. So now Q naught is moving from A to B against electric force. Then work has to be done, right? So and then consider electric potential at point B, that is V plus dV, and electric potential at point A, electric potential at point A, that is V, right? First step, let us consider VA is equal to V, VB is equal to V plus VV, and then small amount of work done, small amount of work done, and moving plus Q naught charge from A to B through a displacement dr, that is against F vector. So in that is W is equal, work done is measured by taking dot product of two vectors, force vector and displacement vector. Now the dot product of two vectors, that is given by product of magnitude of two vectors and cosine of the angle in between them. So angle between F vector and this is actually dr vector. Okay, so distance from point A to point B, from point A to point B, so that is the dr. Dr is the displacement. So the angle between F vector and dr vector, so that is 180 degree, right? Because F vector is anti-parallel to dr vector. So cos 180 degree means that is -1. So in minus F into dr, right? W is equal to F vector is Q naught into E vector, magnitude of F vector, that is F is Q naught E. So minus Q naught E into dr. So W by Q naught is equal to minus E into dr. So call this is equation number 1. And then now by using the definition of potential difference, between A and B, so that is VB minus VA is equal to W by Q naught. So VB not already now mentioned VB is V plus dV, right? V plus dV minus VA is V, that is equal to W by Q naught. So ಇಲ್ಲಿ VV ಏನಾಗುತ್ತೆ cancel ಆಗುತ್ತೆ. So BV is equal to W by Q naught. So call this is equation number 2. Now compare the two equations 1 and 2. From equations 1 and 2, in the minus E dr is equal to dV. So E is equal to minus dV divided by dr. So this is an expression for electric field in terms of electric potential, relation connecting between electric field and electric potential. What is the significance of negative sign? So that is very important here. Negative sign indicates electric potential. Electric potential decreases. Electric potential decreases in the direction of electric field. So that is the significance of negative sign. Okay, right. So this is very, very, very important. Repeated 3-mark derivation. Number of times idu main exam alli bandide. So ಚೆನ್ನಾಗಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. So according to scheme of valuation ಅನ್ನು explain ಮಾಡಿದ್ದೇನೆ. ಈಸಿಯಾಗಿ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು. Next question. Reduce an expression for electric potential energy of system of 2-point charges in the absence of electric field. In the absence of electric field. First here, let us consider the two locations. Choose ಮಾಡ್ಕೋಬೇಕು. First, work done in moving charge Q1 from infinity to point A. So now calculate ಮಾಡಬೇಕಾಗುತ್ತೆ. So work done in moving or bringing the charge. Moving charge Q0, Q1. Moving Q1 from infinity to point A. Actually, so this is equal to 0 because there is no initial electric field. Electric field ಅಲ್ಲಿ charge particle move ಮಾಡಿದ್ರೆ ಅದರ ಮೇಲೆ force act ಆಗುತ್ತೆ. Force act ಆದರೆ ಆಗ work done ಆಗುತ್ತೆ. So in the absence of electric field, charge particle move ಮಾಡಿದ್ರೆ it does not experience any force. So force 0 ಆದರೆ work done is also 0. This is the first step in this derivation. Work done in moving Q1 from infinity to point A is 0. Work done in moving the charge Q2 from infinity to point B. Now work has to be done because Q2 is entering the electric field that is produced by Q1 charge. Now there is electric potential at point B. Because point B at the electric potential that is due to Q1 charge. So work done in moving Q2 charge from infinity to point B adana calculate ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಏನು ಮಾಡಬೇಕು? Electric potential at point B due to Q1 charge adana VB1 ಅಂತ ಮೆನ್ಷನ್ ಮಾಡೋಣ into the moving charge Q2 ಎರಡು multiply ಮಾಡಿದ್ರೆ we will get the work done, right? So work done in moving plus Q2 charge from infinity to point B. That is W2 is equal to electric potential at point B due to Q1 charge, that is VB1. VB1 means electric potential at point B due to Q1 charge. And the moving charge is Q2. So W2 is equal to VB1 is 1 divided by 4 pi epsilon naught. Electric potential at a point due to point charge equation use ಮಾಡಬೇಕು. That is 1 by 4 pi epsilon naught Q by R. So the point charge Q1 ಬರುತ್ತೆ. Distance is R12. So VB1 is 1 divided by 4 pi divided by R12 into Q2. Right? So after that, total work done now calculate ಮಾಡಬೇಕು. Total work done. Total work done is W is equal to W1 plus W2. So W is equal to W1 is 0, W2 is 1 divided by 4 pi epsilon naught Q1, Q2 divided by R12. Okay. So this total work done is stored as electrostatic potential energy. Since W is equal to U, so therefore U is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R2. So this is the expression for potential energy of system of 2-point charges in the absence of external electric field. This is third very important 3-mark derivation in this chapter. Okay. Next question. Derive the expression for capacitance of parallel plate capacitor. Expression for capacitance of parallel plate capacitor. This is also very important 3-mark derivation. First, let us consider two parallel plates. Two parallel plates. One is positively charged. One is positively charged. Another one is negatively charged. So iliro region nanu region 1 and choose ಮಾಡ್ತೀನಿ. In between the plates region 2 and this is region 3 and mention ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Okay. So in between the plates electric field ಹೇಗೆ ಬರುತ್ತೆ? Straight, parallel and equidistant. Actually uniform electric field produce ಆಗುತ್ತೆ. So ಅಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಚೆನ್ನಾಗಿ ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಡಿ. separation between the plates ಏನಿದೆ, separation between the plates actually that should be less than the area of each plate. This point is very important. D should be less than A. So what is the meaning of D? D is separation between the plates. Now consider an observation point in region 1. So a unit positive test charge is placed at point P. One point of the electric intensity now find out ಮಾಡಬೇಕಾದ್ರೆ ಆ point of the unit positive test charge ಇರಬೇಕು. Due to sheet 1 positively charged sheet plus Q0 ಏನಾಗುತ್ತೆ? Plus Q0 will experiences repulsive force, right? Plus Q0 will experiences repulsive force. Due to sheet 2 plus Q0 will experiences attractive force. E2 vector. Okay, so this is E1 vector. This is E2 vector. So in region 1, what is the electric field as I now calculate ಮಾಡಬೇಕು? The net electric field in region 1. Two electric fields acting at the same point which are in opposite direction. So the resultant electric field now calculate ಮಾಡಬೇಕಾದ್ರೆ difference ಮಾಡಬೇಕು, right? And E is equal to E1 minus E2. E1 andre electric intensity at T due to sheet 1. One point ಚೆನ್ನಾಗಿ ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಡಿ. Electric intensity at a point due to uniformly charge the sheet. does not depends on the distance. Does not depends on the distance. And the distance vary or through electric field strength due to uniformly charged sheet with agodilla. Okay. So E1 is sigma by 2 epsilon naught. E2 is also sigma by 2 epsilon naught. Okay. So ಎರಡು cancel ಆಗುತ್ತೆ. So electric field in the first region becomes 0. Other is the same as it is net electric field in region 3. Let me calculate region 3. Now consider an observation point in region 3. A unit positive test charge is placed. Unit positive test charge is placed at point P due to sheet 1. Plus Q naught will experience a repulsive force. Correct? Due to sheet 2, plus Q naught will experience attractive force. So this is E2. So this is E2 vector and this one E1 vector. The resultant electric field E is equal to same E1 minus E2. E1 is sigma by 2 epsilon naught minus sigma by 2 epsilon naught. ಎರಡು cancel ಆಗುತ್ತೆ. So the resultant electric field is equal to 0. ಅಂದ್ರೆ ಈ region 1 ಅಲ್ಲಿ electric field 0, region 3 ಅಲ್ಲೂ electric field 0. So in between the plates electric field ಏನು ಬರುತ್ತೆ ಈಗ find ಮಾಡೋಣ. Now consider an observation point in between the plates. A unit positive test charge is placed at this observation point due to sheet 1 plus Q naught will experiences repulsive force due to sheet 2 plus Q naught will experiences attractive force. That means here E1 vector and E2 vector both are moving in the same direction. E1 vector this is E1 vector. What is this? E2 vector. Both are moving in the same direction. Net electric field in between the plates. That means region 2. ನೋಡಿ ಟೂ ವ್ಯಾಕ್ಟರ್ಸ್ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ರಿಸಲ್ಟೆಂಟ್ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಎರಡು ಏನ್ ಮಾಡಬೇಕು ಆಡ್ ಮಾಡಬೇಕು. ಸೊ E is equal to E1 plus E2. E1 is sigma by 2 epsilon naught. E2 is also sigma by 2 epsilon naught. Sigma by 2 epsilon naught. Add ಮಾಡಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ? Half plus half is 1. Sigma by epsilon naught ಬರುತ್ತೆ. So E is equal to sigma is Q by A epsilon naught. But we want the capacity, right? The potential difference between the plates of capacitor. Potential difference between the plates of capacitor. By using the relation connecting between electric field and potential difference, E is equal to V by D. So V is equal to E into T. So what is the expression for E? E is Q divided by A epsilon naught into D. Here now definition of capacity by using the definition of capacity. So what is the definition of capacity? That is the ratio of electric charge on any one of the plate of the capacitor. Plus Q on the choose manner. What is this? Minus Q. Okay. The ratio of charge on any one of the plate. What is the net charge on the capacitor? That is 0. Plus Q minus Q net charge is 0. So the ratio of charge on any one of the plates over. That is very important. charge on any one of the plate divided by potential difference between the plates. Separation here, right? So divided by V. C is equal to Q divided by V is QD divided by epsilon naught A. Q cancel out. Finally, C is equal to epsilon naught A divided by D. Epsilon naught A divided by D. So what is this? The expression for capacity of parallel plate capacitor. Parallel plate air capacitor. Parallel plate air capacitor. So in the presence of dielectric medium, CD is equal to epsilon naught epsilon or A by D. The tree mark, so it's to mention another sort of more than sufficient. This is fourth very important tree mark derivation. Next question, hopefully. Derive the expression for energy stored in a charged capacitor. Expression for energy stored in a charged capacitor. Okay, so first let us consider the capacitor. Capacitor is a device used for storing the electric charge. Circuit symbol of capacitor, right? This one is connected to a battery. Okay. Battery ಅಂದ್ರೆ positive terminal ಇರುತ್ತೆ ಏನದು negative terminal. Right. So V is the potential difference. Actually, this is positively charged plate, negatively charged plate, and this is having capacitance C. Just a simple derivation. So first here, consider a capacitor of capacitance C, charged with Q, such that its potential in the potential V is equal to, not Q is directly proportional to V. Q is equal to CV, so V is equal to Q by C. So after that, a small amount of work done to charge the capacitor now can be practical. Small amount of work done. Small amount of work done to charge the capacitor. Small amount of work done to charge the capacitor is dW is equal to V into dQ. dW is equal to V andre Q by C into dQ. So ಈಗ ಮಾಡಬೇಕಾಗಿರೋದು total work done, right? Total work done to charge the capacitor from 0 to capital Q. Initially, what is the charge on the capacitor? 0, and finally the charge on the capacitor is maximum. This is final charge and this is the initial charge. Initial charge is 0, final charge is maximum. So ಈಗ ಏನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಎಬೋ ಈಕ್ವೇಷನ್ ಇಂಟಿಗ್ರೇಷನ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. Integration of dw is equal to integration of 0 to capital Q by C into dq. Integration of dw 1 by C is constant, take it as outside. Integration of 0 to capital Q into dq. So W is equal to 1 by C. Integration of Q into dq, that is Q square by 2. The limits varies from 0 to capital Q. So W is equal to 1 by C. First upper limit apply madi, Q square by 2 minus 0. So this work done is stored as electrostatic potential energy. What form of energy is stored in a capacitor? Electrostatic potential energy. Electrostatic potential energy. So U is equal to the Q square divided by 2C. Different forms can now convert ಮಾಡಬಹುದು. U is equal to Q square by 2C. U is equal to Q means CV ಅಲ್ಲ. Q is equal to CV. C square V square. 1C cancel ಆಗುತ್ತೆ. So of C V square ಅಂತ ಬರೆಯಬಹುದು. Or in other words, ನಾವು ಒಂತರ ಬರೆಯಬಹುದು. Or U is equal to ನೋಡಿ of Q ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ, Q by C ಅಂದ್ರೆ B of QB. These are the different mathematical expressions for electrostatic potential energy stored in capacitor. Q square by 2C of CV square of QB. This is very important three-mark derivation. Okay, next question. That is an expression for electric potential energy of system of 3-point charges in the absence of external electric field. But ಈಗಾಗಲೇ potential energy of system of 2-point charges ನಾನು calculate ಮಾಡಿದೆ. So ಈಗ potential energy stored in system of 3-point charges ಅದನ್ನ find ಮಾಡಬೇಕು. So let us consider here the 3 locations A, B and C. First 2 steps same as it is ಬರುತ್ತೆ. Plus Q1 charge is moving from infinity to point A. So what amount of work has to be done? Work done is 0, right? Because there is no initial electric field. There is no initial electric field. Work done in moving plus Q1 charge from infinity to point A is work done in moving. Q1 charge from infinity to point A is 0 because there is no initial electric field. So initial electric field. And then work done in moving plus Q2 charge, okay, from infinity to point B. Now work has to be done against electric field produced by Q1 charge. So that is measured by taking the product of electric potential at B due to Q1 charge into moving charge is Q2. So W2 is equal to VB1. VB1 means electric potential at point B due to Q1 charge. Distance from A to B is R12. So VB1 is 1 divided by 4 by epsilon naught Q1 divided by R12 into Q2. We've already the previous derivation we discussed ಮಾಡಿದೆ, right? ಈಗ work done in moving the third point charge, that is plus Q3 from infinity to point C. Calculate distance from Q1 to Q3 is R13. Distance from Q2 to Q3 is R23. Okay. So work done in moving plus Q3 charge from infinity to point C. So in W3 ನೋಡಿ ಇವಾಗ ಪಾಯಿಂಟ್ ಸಿ ಹತ್ರ ಟೂ ಪೊಟೆನ್ಶಿಯಲ್ಸ್ ಇರುತ್ತೆ ಬಿಕಾಸ್ ಇದು ಟೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಸ್ ಅಲ್ಲಿ ಎಂಟರ್ ಆಗುತ್ತೆ ಕರೆಕ್ಟ್ Q1 ಚಾರ್ಜ್ ಸರೌಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ Q2 ಚಾರ್ಜ್ ಸರೌಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ ಟೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಸ್ ಅಲ್ಲಿ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಎಂಟರ್ ಆಗ್ತಾ ಇದೆ ಈ ಪಾಯಿಂಟ್ ಹತ್ರ ಟೂ ಪೊಟೆನ್ಶಿಯಲ್ಸ್ ಇರುತ್ತೆ ಒನ್ ಇಸ್ due to Q1 charge and another one is due to Q2 charge. So net potential andre VC1 plus VC2 ಮಾಡ್ಬೇಕು VC1 ಅಂದ್ರೆ electric potential at point C due to Q1 charge. VC2 means electric potential at point C due to Q2 charge and the moving charge is Okay, so W3 is equal to VC1. VC1 andre electric potential at C due to Q1 charge. Formula very simple. 1 by 4 pi epsilon naught in Q1 divided by R13. Okay, plus VC2 1 divided by 4 pi epsilon naught. Q2 divided by R2 into the moving charge is Q3. So W3 is equal to literally 1 by 4 pi epsilon naught common take remaining in Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. So what is the meaning of potential energy of system of 3 point charges? Suppose the definition total work done, total amount of work done in bringing 3 point charges from infinity to their respective locations. Actually, that is called potential energy of system of 3 point charges. So the total work done is total work done in W is equal to W1 plus W2 plus W3. So W is equal to W1 is 0, W2 is 1 by 4 pi epsilon naught Q1 Q2 divided by R12 plus W3 is 1 by 4 pi epsilon naught Q1 Q3 Q1 Q3 Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. Okay, and again total work done is stored as potential energy. Finally, U is equal to literally 1 by 4 pi epsilon naught. Now common thing is 1 by 4 pi epsilon naught is common. Remaining is Q1 Q2 divided by R12 plus Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. This is an expression for potential energy of system of 3 point charges in the absence of external electric field. Right. Next one. Derive the expression for potential energy stored in electric dipole in uniform electric field. First here, let us consider the uniform electric field. That means electric field lines are straight, parallel, and equidistant. Now let us consider an electric dipole, that is having pair of equal and opposite charges separated by a small vector distance, and it is directed from vector distance is directed from negative charge to positive charge. The electric dipole having pair of equal and opposite charges. A is the location of minus q, B is the location of plus q, and this is dipole axis. And the dipole moment is also directed from negative charge to positive charge. Theta is the angle made by electric field vector and electric dipole moment vector. So the force acting on plus q due to electric field, that is along the direction of electric field, and force acting on minus q due to the electric field, that is opposite to the direction of electric field. Right. This is F B vector is equal to plus q into E vector, and this one is F A vector is equal to minus q into E vector. So the perpendicular distance between the two forces in Bharate, that is 2a sine theta, right? In the triangle ABO, this is angle theta, because these two are corresponding angles. Sine theta is perpendicular and the OB divided by AB. AB is 2a, so OB is 2a sine theta. Okay. Potential energy stored in electric dipole ಅದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗ್ತದೆ. The first step ಅಲ್ಲಿ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ. First initial consideration ಮಾಡಬೇಕು. If an electric dipole is placed in the presence of uniform electric field, it will experience its torque, right? So torque acting on electric dipole in uniform electric field is torque acting on electric dipole in uniform electric field is tau is equal to P sin theta. Small amount of work done, right? Small amount of work done in rotating electric dipole through small angular displacement d theta against torque. That is dw is equal to tau into p theta. dw is equal to tau is p sin theta into p theta. So normally total work done, total work done in rotating electric dipole from initial angle theta 1 to final angle theta 2. So you got previous equation integration apply model integration of dw integration of limits varies from theta 1 to theta 2 p e sin theta into d theta. Integration of dw is w, p is constant, theta is outside. Integration of theta 1 to theta 2 sin theta. W is equal to p e integration of sin theta d theta, that is minus cos theta. Limits varies from theta 1 to theta 2. So the total work done is equal to minus is taken as outside cos theta. Limits varies from theta 1 to theta 2. W is equal to minus P limits apply ಮಾಡಿ cos theta 2 minus cos theta 1 ಈಗ ಏನು ಮಾಡಬೇಕು to take natural choice to take natural choice ಏನು natural choice ಏನು ಬರುತ್ತೆ theta 1 is equal to 90 degree and theta 2 is equal to theta, right? Now the equation becomes W is equal to minus PE cos theta minus cos 90 is 0. And this total work done is stored as potential energy. So U is equal to minus PE cos theta. This is the expression for potential energy stored in electric dipole in vector form, vector notations within our minus P vector dot E vector and the mention marker. Okay. This is very important for 3 mark again. The next, complete, very important 3 mark derivations each chapter alli finish madidene. So ಈಗ 5 mark derivations discuss ಮಾಡೋಣ. The first one is derive an expression for electric potential due to an isolated point charge. So this is very important 5 mark derivation. Each chapter alli 5 mark derivation maximum ಇದೆ ಕೇಳಿರೋದು. First, let us consider isolated positive point charge plus Q that is located at point O. Okay. Now consider observation point P. Distance from O to P is R. O to P distance is R. Now consider 2 more observation points A and B. A unit positive test charge plus Q naught is placed at point A. Due to plus Q at O, plus Q naught at A will experience repulsive force. Correct? Due to plus Q naught ಏನಾಗುತ್ತೆ repel ಆಗುತ್ತೆ. Okay, right. So this is factor. This time goes to infinity. ಈಗ plus Q naught ನ ಮೂವ್ ಮಾಡಬೇಕು from A to B through displacement dx. Okay, distance from A to B is dx. We go in the P get distance bandu R. Okay, A in the O get distance x ಅಂತ ನಾನು choose ಮಾಡ್ತೇನೆ. B in the A get distance bandu that is a dx. The dotted lines ತಗೊಳ್ಳಿ. So our distance is correct ಆಗಿ ಬರುತ್ತೆ. ಒಂದು ಚೂರು ಮಿಸ್ಟೇಕ್ ಇದ್ದರೆ ನೀವು derivation ಮಾಡಬಹುದು. So distance from ನೋಡಿ O to A is x. This is x, this is R, this is dx. This is dx vector, right? Okay. Diagram ನೋಡಿ ಎಷ್ಟು ಬರೆದರೆ ಸಾಕು. So derivation start ಮಾಡೋಣ. According to according to Coulomb's inverse square law. Okay, according to Coulomb's inverse square law, force acting on plus Q naught due to plus Q F is equal to 1 divided by 4 pi epsilon naught Q naught divided by x square. Okay. Modified to small amount of work. Small amount of work done in moving plus Q naught from A to B. Against A to B against F vector is. So that is dW is equal to F vector dot dx vector. dW is equal to F dx dot product of two vectors, that is given by product of magnitude of two vectors and cosine of the angle in between them, the angle between F vector and dx vector, not F vector and dx vector in between angle is exactly equal to 180 degree. Cos 180 is minus 1. dW is equal to F value, that is 1 divided by 4 pi epsilon naught Q naught divided by x square. Dx. Cos 180 is minus. Right. Next step the total work done in moving what plus Q naught charge from infinity under x is equal to infinity to T under x is equal to R. But Q naught infinite distance x value infinity agate Q naught T hatra bandide andre x value exactly equal to R. So here above equation now integration apply ಮಾಡಬೇಕು. So integration of dW is equal to integration x varies from infinity to x is equal to R minus Q naught divided by 4 pi epsilon naught 1 by x square into dx. Integration of dW is W, so constant terms take it as outside, minus Q naught divided by 4 pi epsilon naught is to constant outside figure. Integration of x is equal to infinity to x is equal to R 1 by x square into dx. Okay, so W by Q naught is equal to and the minus Q divided by 4 pi epsilon naught integration of 1 by x square into dx, that is minus 1 by x. Limits varies from x is equal to infinity to x is equal to R. So W by Q naught is equal to minus is minus plus Q divided by 4 pi epsilon naught 1 by x. Limits x is equal to infinity to x is equal to R. So by the definition of potential, V is equal to W by Q naught. V is equal to W by Q naught. Therefore, V is equal to Q divided by 4 pi epsilon naught. Okay. Limits apply ಮಾಡಬೇಕು 1 by R minus 1 by infinity. 1 by infinity term goes to 0. And finally, we will get V is equal to 1 by 4 pi epsilon naught Q divided by R. So this is the expression for electric potential at a point due to isolated positive point charge. And this is spherical in symmetry. Electric potential due to isolated positive point charge is spherically symmetric. And this is very, very, very important. Repeated 5-mark derivation and this chapter. Next question. Derive an expression for equivalent capacitance. For effective capacitance when two capacitors are connected in series. Just ನೋಡಿ important derivation. Correct ಕೇಳಿಸ್ಕೊಂಡ್ಬಿಡಿ. ಆರಾಮಾಗಿ ಒಳ್ಳೆ ಮಾರ್ಕ್ಸ್ ಸ್ಕೋರ್ ಮಾಡಬಹುದು. So when capacitors are said to be in series, the positive plate of one capacitor is connected to negative plate of another capacitor. This is positive terminal, negative terminal of the battery, and V is the potential difference. But a positive plate of one capacitor is connected to negative plate of another capacitor. Now the capacitors are connected in series. If the capacitors are connected in series, charge on each capacitor is same. Potential difference across each capacitor is not same. Potential difference across each capacitor is different. This point is very, very important. Okay. Now the two capacitors are replaced by a single capacitor that is having equivalent capacity Cs. The equivalent circuit. This is connected to the same battery and the same potential difference, that is V. Positive terminal. This one is negative terminal. Negatively charged plate. This is positively charged plate. And what is this? This is Cs. When capacitors are said to be connected in series, the positive plate of one capacitor is connected to the negative plate of another capacitor, or negative plate of one capacitor is connected to positive plate of another capacitor. If the capacitors are connected in series, charge on each capacitor is same. Potential difference across each capacitor is different. The net potential difference across the combination is equal to sum of potential differences across individual capacitors. So what is the meaning of equivalent capacity? That is the capacity of single capacitor which produces the same effect as the combination. So consider here two capacitors C1 and C2 are connected in series. So that is why the net potential difference V is equal to V1 plus V2. Now by using the formula, Q is equal to CV, V is equal to Q by C. So potential difference across C1 means V1 is equal to Q by C1. And call this equation number 1, call this equation number 2. And the potential difference across C2 is, potential difference across C2 is V2 is equal to Q by C2. Oh, this is equation number 3. Now the two capacitors are replaced by a single capacitor regarding equivalent capacitance CS. If CS is the equivalent capacity in series, then V is equal to Q by CS. Oh, equation number 4. Now the equations 2, 3, 4 in equation number 1. Then we will get Q by CS is equal to Q by C1 plus Q by C2. Q by CS is equal to Q is taken as common 1 by C1 plus 1 by C2. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ Q cancel ಆಗುತ್ತೆ 1 by CS is equal to 1 by C1 plus 1 by C2. The reciprocal of equivalent capacity in series is equal to sum of reciprocals of individual capacitances. Okay, so this is the very important 5-mark derivation. Summa simple ಆಗಿ ನಾನು explain ಮಾಡಿದ್ದೇನೆ. What is the meaning of effective capacity? Capacitor, single capacitor which produces the same effect as the combination. The next derived expression for equivalent or effective capacitance. When two capacitors are connected in parallel. Two capacitors are connected in parallel. We consider again two capacitors C1 and C2. C1 and C2. Now the capacitors are connected in parallel. Capacitors are connected in parallel. We consider the two capacitors C1 and C2. C1 and if positive plates are connected to one common point, the negative plates are connected to another common point. Now the capacitors are said to be connected in parallel. Positive plates are connected to one common point. Okay. The negative plates are connected to another common point. Now the capacitors are in parallel. This is an equivalent capacity, CP. Equivalent capacity is the capacity of single capacitor which produces the same effect as the combination. If the capacitors are connected in parallel, the charge on each capacitor is different. Potential difference across each capacitor is same. And the net charge is equal to sum of charges on individual capacitors. Q is equal to Q1 plus Q. Okay. Now by using the formula, Q is equal to C. Q is equal to C. Charge on C1 is Q1 is equal to C1V. False. The equation number 2. Charge on C2 is Q2 is equal to C2V. False. The equation number 3. If CP is the equivalent, CP is the equivalent capacity, then Q is equal to PPV. False. Equation number 4. Now the equations 2, 3, 4 in equation 1, and we will get CPV is equal to C1V plus C2V. CPV is equal to V is taken as common, C1 plus C2, right? So V ಏನಾಗುತ್ತೆ cancels. CP is equal to C1 plus C2. If more number of capacitors are connected in parallel, effective capacity increases. If the capacitors are connected in series, effective capacity decreases. So here equivalent capacity in parallel is equal to sum of individual capacitors. Sum of capacities of individual capacitors. Capacitances of individual capacitors. And this is also important for 5 mark. This is very simple derivation. The last 5 mark derivation in this chapter, derive the expression for electric potential at a point due to an electric dipole. Okay, first here, let's consider an electric dipole. Electric dipole that is having pair of equal and opposite charges. Separated by a small vector distance. A is the location of minus Q. B is the location of plus Q. The line joining the two charges is called dipole axis. It is directed from negative charge to positive charge. Now consider observation point P. Okay, the distance from A to P is R1. Distance from P to B is R2. Distance from P to center of electric dipole. R. Okay. This is R1, this is R2, and this is position vector of observation point. This is electric dipole moment vector, and theta is the angle made by position vector of observation point and dipole moment vector. The point P lies far away from the center of the electric dipole. Now this angle is also considered as theta. Okay. ಈಗ ಒಂದು imaginary perpendicular ನಾವು draw ಮಾಡಬೇಕು, right? Imaginary perpendicular. What is the distance from A to this point? A to Q ಅಂತ ಮೆನ್ಷನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So that is R1 minus R2. Okay, now let us start derivation. First, let us consider P is equal to Q dot 2A. What is this? Electric dipole moment. ಇದಾದ್ಮೇಲೆ ನಾವು ಮಾಡಬೇಕಾಗಿರೋದೇನು, net electric potential wave at point P due to 2 point charges. ಒಂದು ಪಾಯಿಂಟ್ ಚೆನ್ನಾಗಿ ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಡಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ at a point due to positive charge potential is positive, electric potential at a point due to negative charge potential is negative. So net potential find out ಮಾಡಬೇಕಾದ್ರೆ first positive potential ಆದ್ಮೇಲೆ negative potential ತಗೊಳ್ಳಿ. So net potential at P, V is equal to VB ತಗೊಂತಾ ಇದೀನಿ. VB ಅಂದ್ರೆ electric potential at P due to plus Q at P, that is positive potential plus ಏನ್ ಬರುತ್ತೆ VA, actually the negative potential. V and electric potential at P due to minus Q at A, that is negative potential. ಅದನ್ನ find out ಮಾಡಬೇಕಾದ್ರೆ electric potential at a point due to point charge formula use ಮಾಡಬೇಕು, that is 1 by 4 pi epsilon naught Q by R. So V is equal to VB is positive, that is 1 divided by 4 pi epsilon naught Q divided by R2, and VA is negative, that is minus 1 divided by 4 pi epsilon naught Q divided by R1. So V is equal to Q divided by 4 pi epsilon naught is taken as common, right? 1 by R2 minus 1 by R1. So V is equal to Q divided by 4 pi epsilon naught. What is the LCM here? LCM is R1 into R2. So R2 cancel agade, R1 cancel agade, remaining R2. And call this equation number 1. Is an assumption. If the point P lies far away from O, then that is simple logic. ಏನಾಗುತ್ತೆ ನೋಡಿ, R1 R2, if point P lies far away from the center, R1 is approximately R, R2 is approximately R, R1 into R square. Call this equation number 8. Now in the triangle AQB, cos theta find out ಮಾಡಬೇಕು. Cos theta in the base divided by hypotenuse. AQ ಅಂದ್ರೆ R1 minus R2 divided by AB is 2A. So R1 minus R2 value, that is 2A cos theta, calls the equation number B. Now the equations A and B in equation number 1. So then V is equal to Q divided by 4 pi epsilon naught. So R1 minus R2, that is 2A cos theta divided by R1 into R2 R square, right? But in Q2A, what is that? Electric dipole moment. Karina. So V is equal to 1 divided by 4 pi epsilon naught. Q into 2A is P cos theta divided by R square. The expression for electric potential at general point due to electric dipole. So in vector notations, the formula can also be written in the form 1 by 4 pi epsilon naught P vector dot R cap divided by R square of the variable. Or in other words, V is equal to 1 divided by 4 pi epsilon naught P vector dot R vector divided by R cube is the variable. Okay. Complete, very important 5 mark derivations. Finish short there. Right. Okay, so thank you everyone. Next video current electricity discuss ಮಾಡ್ತೀನಿ.